This is the EdExcel GCSE 9-1 Maths Paper 1 from the higher tier, and it's a non-calculator paper from the June 2017 series. Question number 1. The scatter graph shows the maximum temperature and the number of hours of sunshine in 14 British towns on one day. We have the number of hours of sunshine and the maximum temperature in degrees C. One of the points is an outlier, and for part A, we have to write down the coordinates of this point. Well, if we take a look at the data given to us, this point here does not follow the general trend and pattern of the rest of the points here. So this point over here is an outlier. So the coordinates of that point, well, we are going 10 across and 19 up. So the coordinates of this point are 10, 19. For part B, for all the other points, we have to write down the type of correlation. Well, as the number of hours of sunshine increases, so does the maximum temperature in degrees C, and therefore we have a positive correlation. For part C, on the same day in another British town, the maximum temperature was 16.4 degrees C. For part C, we have to estimate the number of hours of sunshine in this town on this day. Well, if we go back to our scatter diagram, to figure out how many hours of sunshine we have, given we have a maximum temperature of 16.4, we would have to draw a line of best fit. Now the line of best fit goes through as many points as possible. So here we have a line of best fit, and we have a maximum temperature of 16.4. So 16.4 is over here. So we draw a horizontal line across, and then we draw a vertical line down from this point over here. So we draw a vertical line going down. So when we come to think about the number of hours of sunshine we have, you can see here we've got 12.9 hours. So therefore we have 12.9 hours of sunshine on this day. For part D, a weatherman says temperatures are higher on days when there is more sunshine. Does the scatter graph support what the weatherman says? Give a reason for your answer. Well, over here, if we go back to the scattergram, apart from this particular point here, you can see as the number of hours of sunshine increase, so does the maximum temperature. So this will suggest that the more hours of sunshine we have, the higher the maximum temperature. Let's just write that down. So, of course, the scatter graph supports the weatherman's statement, because for majority of points, more hours of sunshine suggest a higher maximum temperature. Question 2, we have to express 56 as the product of its prime factors. So we have 56 over here, And then we need to find two numbers which multiply to give 56. Well, we have 2 and 28. The 2 we can't split up any further, it's a prime number. However, the 28 we can split up into 2 and 14. 2 we can't split up any further, it's a prime number. However, 14 we can split up into 2 and 7. 2 we can't split up any further, it's a prime number. 7 we can't split up any further, it's a prime number. So therefore, when we come to express 56 as the product of its prime factors, you can see 56 is equal to 2 times by 2 times by 2 times by 7. Of course here, 2 times 2 times 2, that's 2 cubed, and then we are multiplying this by 7. So 56 in the product of its prime factors is given by 2 cubed times 7. Question 3, we have to work out 54.6 times 4.3. Well, to do this, we can split up the 54.6 and the 4.3 into its digits. So first of all, let's draw a grid. So we have something looking like this. The 4.3 we can split up as 4 and 0.3. Of course, adding these together gives the 4.3. And 54.6 we can split up as 50, 4 and 0.6. And of course, adding these together gives the 54.6. Now let's multiply in our grid. 4 times by 50, that's 200. 4 times by 4, that's 16. 4 times by 0.6, that's 2.4. 0.3 times 50, that's 15. 0.3 times 4, that's 1.2. 0.3 times 0.6, that's 0.18. So what we now need to do is add all these numbers together. So we have 200 plus the 16 plus the 15 plus the 2.4 plus the 1.2 plus the 0.18. So we now need to add all these together. Here we've got the 8, 4 plus 2, that's 6, plus another 1, that's 7. Decimal point stays where it is. Then we've got 6 plus 5, that's 11, plus 2, that's 13, plus another 1, that's 14. So we have the 4 which goes here, and then we carry forward an extra 1. So we've got 1 plus 0 plus 1 plus 1, that's 3. And then we've got the 2 over here. So you can see that 54.6 times 4.3, that's 234.78. Question number 4. The area of the square ABCD is 10 centimeters squared, and you can see the length of one side of the square is x plus 3 centimeters. We have to show that x squared plus 6x is equal to 1. Well, the area of a square Here this will be given by x plus 3 all squared. And we know that this is equal to 10. We now need to somehow show that x plus 3 all squared equals 10 is the same as x squared plus 6x equals 1. Well, if I expand on the left hand side, we've got x squared plus 6x plus 9, and here we've got 10. And now if I subtract 9 from both sides, you can see that x squared plus 6x is equal to 1. And this is exactly what we wanted to show. Question number 5. This rectangular frame is made from 5 straight pieces of metal. The weight of the metal is 1.5 kilograms per meter. We have to work out the total weight of the metal in the frame. Well, if we take a look at the rectangular frame, you can see here we've got 12 meters, here we've got 5 meters. We need to find out the total length of all of this frame. So for that, we need to find out the length of the diagonal over here. And we can find that out through Pythagoras. So we have, if I call this side x, then x squared is equal to 12 squared plus 5 squared. So therefore x squared is equal to 169, and therefore x is equal to 13, which is the square root of 169. So here we've got 13 meters. Opposite lengths in a rectangle are equal, so here we've got 12 meters, here we've got 5 meters. So therefore, for the total length, we've got 5 plus 5 plus 12 plus 12 plus 13, which is equal to 47. We have 47 meters for the total length. Now we know already from the question the weight of the metal is 1.5 kilograms per meter. So for every 1 meter we have 1.5 kilograms. Now here we have 47 meters. To go from 1 to 47, of course here we just multiply by 47, so we need to multiply the 1.5 by 47. So 1.5 times 47, that will equal 70.5. So we've got 70.5 kilograms for the total weight. So we've got 70.5 kilograms. Question number 6. The equation of the line L1 is y equals 3x minus 2. The equation of line L2 is 3y minus 9x plus 5 equals 0. We have to show that these two lines are parallel. First of all, to show that two lines are parallel, we need to write both lines in the form y equals mx plus c. M here represents the gradient. C will represent the y-intercept. So if we take a look at line L1, that's already in the form y equals mx plus c. We have y equals 3x minus 2, and therefore you can see that the gradient of this line is equal to 3. And if we take a look at line L2, we have 3y minus 9x plus 5 equals 0. And if we rearrange this to get it in the form y equals mx plus c, well, first of all, we need to add 9x to both sides and then subtract 5. In other words, we need to take the minus 9x plus 5 to the right hand side. So we've got 3y equals 9x minus 5. And if I divide through by 3, you can see y is equal to 3x minus 5 over 3. You can see here that the gradient is equal to 3. So therefore, as L1 and L2 have the same gradient, we can conclude that L1 and L2 are parallel. Question number 7. There are 10 boys and 20 girls in a class. The class had a test. The mean mark for all the class is 60. The mean mark for the girls is 54. We have to work out the mean mark for the boys. Well, we know that the mean is given by the sum of all the marks over the number of pieces of data we have. We can use the information given about the entire class to find out the total mark for all of the class. So for the total class, we can find out what the sum of their marks is. And the reason I want to do that is because that will allow me to find out the total for the boys and then find out the mean mark for the boys. So if we rearrange this equation, the sum of all the marks is equal to the mean multiplied by the number of pieces of data. So for the entire class, the total marks is the mean, which is 60, multiplied by the total number of students in the class, 10 plus 20, which is 30. So of course the total marks is equal to 1800. So for the girls, we can find out their total score. We've got 54 for the mean mark, multiplied by the number of girls, which is 20. So the total marks for the girls is 1080. And for the boys, well, the total score for the boys is equal to 1800, which is the total score for the class, minus 1080, which is the score for the girls. Of course, the total score for the boys is 720. And therefore, the mean is equal to 720 divided by 10, which is 72. So the mean mark for the boys is 72. Question 8. For part A, we have to write 7.97 times 10 to the minus 6 as an ordinary number. Well, we've got the 7.97 and we need to move this decimal place 1, 2, 3, 4, 5, 6 units to the right. So the decimal point goes here. And for The rest we add in the 0 placeholders. So as an ordinary number, we've got 0.000000797. Now for part B, we have to work out the value of 2.52 times 10 to the 5 divided by 4 times 10 to the minus 3. Well, here, what this is the same as is 2.52 times 10 to the 5 divided by 4 times 10 to the minus 3. Now, 2.52 divided by 4, that's 0.63. And then 10 to the 5 divided by 10 to the minus 3. Well, here, because we've got the same base in 10 and we're dividing, we subtract the powers, so we've got 10 to the power of 5 take away minus 3. So here we've got 0.63 times by 10 to the power of 8. Now for standard form, that's when a number is of the form a times by 10 to the power of n, where a is in between 1 and 10. So the 0.63, that's not in between 1 and 10. If I multiply the 0.63 by 10, we have 6.3, and because I've times this by 10, I'd have to divide this by 10, and if I divide 10 to the 8 by 10, I get 10 to the 7. So therefore this result is equal to 6.3 times by 10 to the power of 7. Question 9. Jules buys a washing machine. 20% VAT is added to the price of the washing machine. Jules then has to pay a total of £600. What is the price of the washing machine with no VAT added? Well, if 20% VAT is added to the price, that means that the £600 given here would correspond to 120%. And what we need to do is find out the original price, which would correspond to 100%. Well, here we can find out what 10% is first, and then once we have found out what 10% is, we can use this information to find out what 100% is. So to go from 120 to 10, we would have to divide by 12. So first of all, we need to divide 600 by 12. 600 divided by 12, that's 50. So 10% would correspond to £50, and then from 10% to 100%, we would have to multiply by 10. So we would have to multiply by 10. So therefore, 50 times by 10 is 500. So therefore, the price of the washing machine with no VAT added is £500. Question number 10. We have to show that x plus 1, lots of x plus 2, lots of x plus 3 can be written in the form ax cubed plus bx squared plus cx plus d, where a, b, c and d are positive integers. Well, you can see here, well, we'll begin with the x plus 1, lots of x plus 2, lots of x plus 3, and we first of all multiply the x by the x. So here we get x squared, and then we've got 1x, and we've also got another 2x, so that gives us 3x. And then we've got 1 multiplied by 2, which is 2. So we've got x squared plus 3x plus 2, lots of x plus 3, which we now need to expand. So now let's take a look at expanding this. X squared times by x, that gives x cubed. And then x squared times by 3 gives 3x squared. And then we've got here the 3x times by x. So we've got here 3x squared plus another 3x squared, which is 6x squared. And then we've got, in terms of the x's, 2 multiplied by x, and then we've got 3x multiplied by 3. So we've got 2x plus 3x, that's 5x. Rather, 3x times by 3x, that's 9x, plus another 2x, that's 11x. And now in terms of the numbers only, 2 multiplied by 3, that's 6. So what we end up with is x cubed plus 6x squared plus 11x plus 6. Question 11, the graph of y equals f of x is drawn on the grid. That's what we see here. And for part A, we have to write down the coordinates of the turning point of the graph. Well, the turning point would correspond to this minimum point given over here. So this is the turning point of the graph. It has coordinates 1 across, 3 down. So we've got coordinates 1 minus 3. For part B, we have to write down estimates for the roots of f of x equals 0. Well, where f of x equals 0 is where the graph crosses the x-axis, and that's here, and it's also here. And you can see those coordinates are, well, as roots we've got x equals minus 0.75 and 2.75. For part C, we have to use the graph to find estimates for f of 1.5. So f of 1.5 means we find the 1.5 here, and if we go across, we can find the corresponding y coordinate. So here you can see the corresponding y coordinate is minus 2.8. So for f of 1.5, you'd find this to equal minus 2.8. Question number 12. For part A, we have to find the value of 81 to the power of minus 1/2. Well, this is the same as 1 over 81 to the power of 1/2. And raising something to the power of 1/2 is the same as taking the positive square root. So the positive square root of 81 is 9. So therefore, 81 to the minus 1/2 is the same as 1/9. For part B, we have to find the value of 64 over 125 to the power of 2/3. Well, here, this is the same as raising, well, here this is the same as cube rooting the 64. So we've got cube root 64 over cube root 125, and then squaring this result. So if we work this out, cube root 64, that's 4. So we've got 4 and then on the bottom cube root 125, that's 5. So we've got 4/5 squared, which is equal to, well, 4 squared, that's 16, 5 squared, that's 25. So the value of 64 over 125 to the power of 2/3 is 16 over 25. Question 13. The table shows a set of values for x and y, and y is inversely proportional to the square of x, and we have to find an equation for y in terms of x for part A. Well, if y is inversely proportional to the square of x, we have y, inverse proportional sign, and then here we've got 1 over x squared. And of course here this is the same as y equals k over x squared for some constant k. Now we can find out the value of k by using these values here. For example, when x is equal to 1 and y is equal to 9, we have 9 equals k over 3 squared, so therefore k is equal to 9 multiplied by 3 squared, 9 times by 9. Rather, here we've got x equals 1, so here we've got 9 multiplied by 1 squared, which is equal to 9. So because k is equal to 9, we can conclude that y is equal to k over x squared. Now for part B, we have to find the positive value of x when y is 16. Well, when y is, here, sorry, we've got 9. So when y is equal to 16, we've got 16 equals 9 over x squared. X squared is equal to 9 over 16. So therefore x is equal to the positive square root. Well, technically when we square root here, we're going to have plus minus 9 over 16 square rooted. So we've got plus minus 3 over 4. We want the positive one. So x is equal to 3 over 4. Question 14. White shapes and black shapes are used in a game. Some of the shapes are circles. All the other shapes are squares. The ratio of the number of white shapes to the number of black shapes is 3:7. The ratio of the number of white circles to the number of white squares is 4:5. The ratio of the number of black circles to the number of black squares is 2:5. We have to work out what fraction of all the shapes are circles. Well, given this statement here, that the ratio of white shapes to black shapes is equal to 3:7. What we can do here is recognize that the fraction of white shapes is equal to 3/10, and the fraction of black shapes is equal to 7/10. We also know that the ratio of white circles to white squares is equal to 4 to 5, and therefore the fraction of white circles is equal to 4 over 9, and the 4 over 9, and the fraction of white squares is 5 over 9. We also know that the ratio of black circles to black squares is equal to 2 to 5. So therefore, the fraction of black circles is equal to 2 over 7, and the fraction of black squares is 5 over 7. So we have to find out the fraction of shapes which are circles. Well, if we think about this, the fraction of white shapes is 3/10, and of those 3/10, 4/9 of those will be white circles. So here, what we can say is 4/9 of the 3/10 are white circles. So if I actually work this out, I've got 12 over 90, which is 2 over 15. So I've got 12 over 90, which is equal to 2 over 15. So this is the fraction of shapes which are white circles. So here, these are white circles. Okay, and we've got 7/10 of the shapes being black shapes, and of those 7/10, 2/7 of those are black circles. So we've got 2/7 of the 7/10. Well, if I actually work out what this is, I've got 14 over 70, which is 1/5. So here, 1/5 of the shapes are black circles. And we're finding out what fraction of all the shapes are circles. So therefore, we've got here the 2/15 plus the 1/5. So if I work this out, well, I'll leave it over 15 over here, and then the 1/5 we can write over 15th. 1/5 is the same as 3/15. So here I'm going to get 5 over 15, which is 1/3. So therefore, 1/3 of shapes are the circles. So here I end up with 1/3. Question 15. A cone has a volume of 98 centimeters cubed. The radius of the cone is 5.13 centimeters. For part A, we have to work out an estimate for the height of the cone. And we're given that the volume of a cone is equal to 1/3 pi r squared h. So we are finding out an estimate for the height. Well, here we can round up the 98 to 100. So the cone we're saying has a volume of 100 centimeters cubed. The radius of the cone is 5.13. We can round this down to 5 centimeters. And the value of pi, which we know equals 3.14, etc., we can round this value to 3. Now, we know already that V is equal to 1/3 pi r squared h. So if we rearrange for h is equal to 3v over pi r squared. So using the approximations, so let's just write this down. Using the approximations, we've got h, which is equal to 3 times by v. So we've got 3 times by 100 over pi, lots of r squared. We're saying this is 5 squared. And we've also said that pi is approximately 3. So here we've got 3 lots of 5 squared. It's as though this and this cancel out. We've got 100 over 25, which is 4. So we're saying that the height of the cone is approximately 4 centimeters. Now for part B, John uses a calculator to work out the height of the cone to 2 decimal places. Will your estimate be more than John's answer or less than John's answer? Give reasons for your answer. Well, in part A, the numerator was increased, and that makes sense because the 98 here, which was the volume, was rounded up to 100, and the denominator was decreased, and that makes sense because pi was rounded down to 3 and the radius of 5.13 was rounded down to 5. So therefore we have a larger estimate than the actual value. Question 16. N is an integer greater than 1, and we have to prove algebraically that n squared minus 2 minus n minus 2 all squared is always an even number. Well, over here, we begin with the n squared minus 2 minus n minus 2 all squared. And if we try to simplify this as much as we can, we've got n squared minus 2 minus, and then if I expand and simplify n minus 2 all squared, and notice how I've opened up the bracket here, we end up with n squared plus 4n, rather here n squared minus 2n, minus another 2n, that's minus 4n, plus 4. So if I tidy up this even more, we've got n squared minus 2 minus n squared plus 4n minus 4. So we've got here 4n minus 6, and if I take out a 2 as a common factor, we've got 2 lots of 2n minus 3. Now here, because n is greater than 1, the minimum integer value for n over here will be 2. So we've got 2 times by 2 minus 3. 4 minus 3, that's going to be 1. So because n is greater than 1, 2n minus 3 will always be positive. Okay? And therefore, Any positive integer multiplied by 2 is even. So this result here is always an even number. Question 17. There are 9 counters in a bag. 7 of the counters are green, 2 of the counters are blue. Ria takes at random 2 counters from the bag. Work out the probability that Ria takes 1 counter of each colour. You must show your working. Well, here there's 2 instances. We pick a counter from the first bag and then pick a counter from the second bag. So what we can do here is draw a tree diagram. So here is our tree diagram. Now we've got 9 counters in total, and of those 9 we know that 7 are green. So therefore 2 must be blue. So we've got 2 over 9 over here. Now we're assuming that we don't replace the counter, so therefore the total number of counters we got now is out of 8. And if we take a green out, we're going to have 6 here, and we're going to have 2 over 9 remaining. We've got green over here, that's 7 over 9, rather 7 over 8. And then blue over here, that'll be 1 over 8. And we're finding out the probability that it takes 1 of each colour. Well, if we take 1 of each colour, we're looking at the probability that we take a green and then a blue. So we've got green and then blue, and then we've got blue and then green. So then here we've got probability of blue then green. So if I work this out, we've got here 7 over 9 multiplied by 2 over 9, rather 2 over 8 rather, and then we add on 2 over 9 multiplied by 7 over 8. So if I work this out, I'm going to have 14 over 72 plus another 14 over 72. So here we've got 28 over 72, which I can simplify to 7 over 18. So it turns out we get 7 over 18. Question 18. ABCD is a rhombus. The coordinates of A are 5, 11. So let's just add this to the diagram. We've got 5, 11 here. The coordinate, the equation of the diagonal DB is y equals 2x plus 6. So this line over here, I'll just add it in as equation, y equals 1/2 x plus 6, and we have to find an equation for the diagonal AC. So here we've got the diagonal AC. Now what we should know already is these 2 lines are perpendicular to each other. So the diagonals of a rhombus are perpendicular to each other. So if we know that the equation over here is y equals 1/2 x plus 6, that means that the gradient of dB is equal to 1/2, and because the line AC is perpendicular to BD, we can therefore conclude that the gradient of AC is perpendicular to this gradient. So here we're going to have minus 1 over 1/2, which is minus 2. So the gradient of AC is minus 2. So we can find out the equation of AC if we use the point A, which has coordinates 5, 11. Then we've got, if we use y equals mx plus c, we've got 11 equals minus 2 lots of 5 plus c. 11 equals minus 10 plus c, and therefore c is equal to 21. So c is equal to 21, and therefore y is equal to minus 2x plus 21. Question 19. Or ABC is a parallelogram, or A is equal to A and OC is equal to C. X is the midpoint of the line AC, and OCD is a straight line, so that the ratio OC to CD is equal to K to 1, and given that XD is equal to 3C minus 1/2 A, we have to work out the value of K. Well, let's take each of these statements in turn. First of all, we know that X is the midpoint of the line AC. So let's just draw on the line AC, that is over here, and half of this is where X is. So X we're predicting is somewhere over here. Okay? So X is over here. And what we also know is OCD is a straight line. So what we're going to do is extend this line here, and then here somewhere we've got the point D. And what we also know is that X to D is equal to 3C minus 1/2 A. So let's just add this here. X to D, that's this line here, is equal to, let's just write this down, XD is equal to 3C minus 1/2 A. And we know that OC to CD is equal to K to 1. So if we think about this statement, OC to CD is K to 1. So this tells us, well, if I work out OC over CD, this is equal to K over 1, and therefore you can see here CD is equal to 1 over K lots of CD. CD is equal to 1 over K lots of OC, rather. Okay? So how does this help us? Well, here 1 over K lots of OC will simply be 1 over K lots of the vector C. So here we've got 1 over K lots of the vector C. Okay, so how does this help us? Well, what we can do is find out what AC is, and then find out what half of that is, from which we can find XD. So if we work out what AC is, starting at A, finishing at C, that will equal AO plus OC. So if I work this out, it turns out we get minus A plus C. So what we can now do is find out what we can find out what AX is as well, which is going to be half of this. So AX, which is equal to XC, this is equal to 1/2. AC. So here we've got 1/2 lots of minus A plus C. Okay, so if I add this to the diagram, this over here is equal to minus 1/2 A, if I expand out as well, plus 1/2 C. Okay, now let's find out the vector OX. So if I find out the vector OX over here, the vector OX, this will equal, starting at O finishing at X, well, we've got OA plus AX. So we've got OA plus AX. So OA, that's A, and AX, that's minus 1/2 A plus 1/2 C. So here A minus 1/2 A, that's just 1/2 A, and then I've got 1/2 C. So here we end up with 1/2 A plus 1/2 C. So this over here is 1/2 A plus 1/2 C. Now we can find out what XD is in terms of all of these as well. So XC, rather XD, if we work out what XD is, XD is equal to, well, starting at X finishing at D, we've got XO plus OC plus CD. So if I work all of this out, XO, we know that's minus 1/2 A minus 1/2 C. So here we've got minus 1/2 A minus 1/2 C. OC, we know that's just C. And then we're going to add on what CD is, which is 1/K, lots of C. So if I tidy all of this up, well, we'll leave this alone for a second. What we know then in total is that this bit over here, if I just copy and paste this over here is equal to what we have over here. They're both equal to XD. So here, these are the same. So this cancels with this. I've got minus 1/2 C plus another 1/2 C. That's going to be 1/2 C. And if I take this over to the other side, we've got on the right hand side 5/2 C, and on the left hand side I've got the 1/K C. So therefore we've got 1/K equaling 5/2, and therefore K is equal to 2/5. So I've got K equals 2/5. Question 20, we have to solve algebraically the simultaneous equations x squared plus y squared equals 25 and y minus 3x equals 13. Well, if I call this top one equation 1 and the second one equation 2, from equation 2, okay, so from equation 2, you can see that y is equal to 3x plus 13. We will now substitute in equation 3 into equation 1. So I've got x squared plus y squared, which is now 3x plus 13 all squared. This is equal to 25. we now need to tidy all this up to find the x coordinates and then use that to find the corresponding y coordinates. So I've got x squared plus 9x squared plus, well, here I'm going to have two lots of 3 times by 13, which is 78. So I've got here 78x plus 169 equals 25. If I take everything over to one side and simplify, we've got 10x squared plus 78x plus 144 equals 0. If I divide by 2, so dividing by 2, we've got 5x squared plus 39x plus 72 equals 0. We now need to solve this. So here we need to find out two numbers which multiply to give 5 times 72, which is 360, and which add to give 39. You'd find those two numbers to be 24 and 15. So I can rewrite what I have here in terms of the numbers I found here. So we have 5x squared plus 15x plus 24x plus 72 equals 0. And if I split this down in the middle, we can factorize the left bit and the right bit. So I'm going to have here 5x lots of x plus 3. And here I'm going to have 24 lots of x plus 3. And all of this is equal to 0. So grouping the terms together, you'd find 5x plus 24 lots of x plus 3 equals 0. We now need to solve this. So from this bracket you can see x is equal to minus 24 over 5 and also minus 3. And now we need to substitute these into equation 3 to find out the corresponding y coordinates. So when x is equal to minus 24 over 3, y is equal to 3 lots of minus 24 over 3 plus 13. So we've got minus 72 over 5. Sorry, we've got 5 over here. So we've got minus 72 over 5 plus 65 over 5, which is minus 7 over 5. Okay, so let's just straighten out these fraction lines. And then when x is equal to minus 3, y is equal to 3 lots of minus 3 plus 13, which is minus 9 plus 13, which is 4. Now does it ask for the coordinates? No, it doesn't. So we can give our solutions as follows. When x is equal to minus 24 over 5, y is equal to minus 7 over 5. Let's just write this down actually in full. So here we've got solutions. When x is equal to minus 24 over 5, the corresponding y coordinate is minus 7 over 5. And we've also got when x is equal to minus 3, y is equal to 4. So this is our solution. Question number 21. ABCD is a quadrilateral. AB is equal to CD, that's shown here. The angle ABC is equal to the angle BCD. We have to prove that AC is equal to BD. So what we need to show here is, to prove this, we need to show that if I just show the diagonals, we need to prove that the triangle ABC is congruent to the triangle BCD. So, first of all, you can see BC is common to both triangles. So BC is common to both triangles. We also know that AB is equal to CD. So AB is equal to CD. This is a statement which is given. And we know that ABC, the angle ABC, is equal to the angle BCD. This is also given. And because of these three statements here, we can conclude that the triangle ABC and the triangle ACD is congruent. So ABC and ACD are congruent, and therefore we have the reason for this is side angle side, and because of that we can conclude AC is equal to BD. Okay, because the triangles are congruent. So this length is the same as this length here. Question number 22. The diagram shows a hexagon ABCDEF. And that's what we see here. ABEF and CBED are congruent parallelograms where AB equals BC, which is equal to x centimeters, and P is the point on AF and Q is the point on CD, such that BP equals BQ equals 10 centimeters. And given that the angle ABC is equal to 30 degrees, we have to prove that the cosine of BPQ is equal to 1 minus 2 minus root 3 over 200 multiplied by x squared. Well, here I think it will be a good idea to sketch the two triangles separately. So I've got this triangle here. Okay, just copy and paste it. And what's happening is we've got this other triangle here. So let me just show this here. We've got the point B over here and point B over here. We've got A and C here. Here we've got X. Here we've also got X. And here we've got P. And here we've got Q. And here we've got 10. And here we've also got 10. We've got 30 degrees over here. That was given to us in the question. And we've got the angle over here, which is what we're finding. And you'd also find AC is equal to PQ. Now, because AC is equal to PQ, and that's because if I show this here, this is equal to this, and that should make sense from the diagram. If I somehow know AC, then I know PQ. And if I know PQ, I can use the cosine rule over here to find out this angle here. Now to find AC, I need to use the cosine rule here for lengths. So, AC squared is equal to x squared plus another x squared minus 2x squared times by the cosine of 30. So if I actually write this out in full, it might make more sense. So AC squared is equal to AB squared plus BC squared minus 2 lots of AB times by BC times by the cosine of the angle ABC. So if I work this out, we get this over here. Okay, and now we need to somehow simplify all this. So AC squared is equal to 2x squared minus 2x squared times by the cosine of 30. Cosine of 30 is root 3 over 2. So I've got 2x squared minus another 2x squared times by root 3 over 2. So this and this cancel. So I end up with, if I factorize out the x squared, we end up with 2 minus root 3 x squared. So that's what AC squared is. And this will of course equal PQ squared. So therefore PQ squared is equal to 2 minus root 3 x squared. So now I can use a cosine rule here. So I've got the cosine of the angle PBQ, which is equal to, if I just grab my ruler, well here we've got PB squared plus BQ squared minus PQ all squared over 2 multiplied by PB multiplied by BQ. So here we've got 10 squared plus 10 squared, so that is these lengths here, and then we subtract off PQ squared, so we subtract off 2 minus root 3 x squared, and then we're going to divide by 2 times by 10 times by 10. So let's work all of this out. So here, if I grab my ruler once again, I've got 100 minus 2 minus root 3 x squared over 200, which I can split up even further as 100 over 200 minus, well, 100 plus 100 is 200 rather. So here we've got 200 over 200 minus 2 minus root 3 x squared over 200. So here is what we end up with. So if I tidy all of this up, you can see we end up with 1 minus, and just grab the ruler, 2 minus root 3 x squared over 200. So this is what we end up with, and that's exactly what we wanted to show.